Should we start?
Yes, madam. We will begin, madam. In the meantime, I'll ask the students to join, madam. Okay, ma'am.
No problem, sir.
Okay, ma'am. Thank you, ma'am.
Thank you, sir. So, students, have you seen that? Have you done the classless example which I have given you? Have you done the classless example which I have given you last time? Everyone is done with the classless example which I gave you. Come back. Shrikant, Tagore, Navya, Rajkumar, Hariprasad.
No, ma'am.
Oh, sure. Anyways, so no problem then. So what we will do today, we will then start with another routing protocol, and in like the next class, you should be done with the classless which I gave you, right? So yes, so the next dynamic routing protocol, we have done two dynamic routing protocols. We have done RIP, we have done EIGRP. So the next dynamic routing protocol we are going to do is OSPF. This is the last routing protocol. Open shortest path first. Version 2, version 3, version 1. Version 1 is not in use. Version 2 is by default we use for IP version 4, and version 3 we by default use for IP version 6. So we have open shortest path first. Features, just like EIGRP, if you remember EIGRP, I have written some features that it is Cisco proprietary. Now it has become an open standard and it supports classless. Like this, for the OSPF, it is from very starting, it is an open standard. That means it is supported on all the vendor platforms like Cisco, Huawei, Juniper, everyone understands, right? So it is open standard. Then second, it supports classless, right? Then third, it supports authentication. That means for the neighborship, if you are configuring the authentication password on one side, the same authentication password should be configured on another side. So two types of authentication, plain text and MD5. Plain text is just like as a normal password, which is very plain, right? Is visible to everyone. MD5 is encrypted. Encrypted password, and it keeps on changing. You can even configure the time that after every 2 hours, this should change, right? And this is plain, no encryption, right? So it supports both. Then you have to put manual summary. Unlike EIGRP or RIP version 2, where you have to where you don't have to do anything. I hope that you remember that we were writing no auto summary in RIP version 2 and EIGRP. In EIGRP, you were writing no auto summary. That means you don't want summary. Here, by default, no auto summarization. So if you want summarization or summary of the route, you have to put manual summary of the route. So these are the features of OSPF. Now, neighborship conditions. What are the neighborship conditions? For the two routers to become neighbor in OSPF, just like it was, this is a point-to-point link. So it should be in the same area, right? So first condition is same area. Just like EIGRP, the routers were in the same autonomous system number. Here the routers should be in same area, point to point. And the area numbers varies from 0 till 65535. Second condition, that point to point, same subnet. Definitely. Otherwise, the WAN link will not come up if they are not in a point to point or in a same subnet. Third is same hello timer. Hello timer is nothing but a timer in which a router sends its hello. So it says, hello, I am OSPF packet. Hello, I am also OSPF packet. So in after every 10 seconds, the router sends the hellos. Fourth criteria is same dead timer. Dead timer means if I am not listening any hello from my neighbor for 40 seconds, that means 4 times, if 4 hello packets are skipped, right? 40 seconds. That means I'm going to declare my neighbor as dead. So if they want to become neighbors, they have to have these criteria as same. Fifth, optional. If you are configuring authentication on one, then the same authentication password has to be configured on another router. So this is an optional, but if you are configuring, then it has to be on the point-to-point link. Same. Any doubts here? Any doubts here? Today is the 10th day of our session. Have you learned anything? Are you learning anything? I'm just teaching you. So probably next week I'm going to again take a test of you, right? Where I will be giving a very basic questions, but I just want to judge your knowledge that how much you have grabbed, right? So this is the neighborship criteria for OSPF. Now, OSPF follows an algorithm made by Frenchmen to calculate the best path. You know that the best path is always flooded in the routing table. So to calculate best path in OSPF, we have an algorithm. Algorithm is made by a Frenchman, Dijkstra. Dijkstra was a Frenchman who developed this algorithm, right? And this, to calculate the best path, it always creates its shortest path tree. This algorithm, it works. And the metric it uses to calculate the best path to the destination is cost, which is inversely proportional to the bandwidth. That means the best the bandwidth, the best is the cost. The highest bandwidth path is selected, or this should be higher, you know. The more the bandwidth, the best is the path. Simple funda. So it is inversely proportional. That means least cost path is selected. Least cost path is selected. Right? Least cost means highest bandwidth. Highest bandwidth. So doubts here? All good, all clear, everyone? So that means if a router wants to send a packet and it has the multiple paths to reach to a particular destination, let's say here, this is the source and this is the destination. And this is 1 gig path, this is 10 gig path, this is 40 gig path. And this is path number A, B, and C. I have configured OSPF algorithm in between site 1 and site 2. Which path it should select? Which path it should select?
Path B.
Path A.
B.
Path B.
C, ma'am.
C. Very good. So highest bandwidth is selected. So it is a very plain algorithm. It is a very plain protocol. It doesn't see lot of parameters just like EIGRP was seeing my delay, my load, my reliability, maximum transmission units, and lot bandwidth and lot of parameters. No, if you remember EIGRP, parameters. Here only a single parameter, bandwidth, and that's all. It's done. The best the bandwidth, the best is the path. Now, if you will see, it always creates the shortest path tree. I told you, SPT. So its design appears to you in the form of branches. How? Like this. If you will join an organization, you will see this protocol a lot in use. This is the maximum used protocol in every organization. This is R1, R2, R3, R4, R5. This is area 0. This is area 1. This is area 2. This is area 2. So the point-to-point route links has to be into the same area, point-to-point links. Unlike EIGRP, where whole router were in the same area, here the interfaces are in the same area. So same area, area 1, area 1, same area, area 2, area. Can you hear me?
Yes, ma'am.
See, so here the concept of area comes. The point-to-point has to be into the same area. Point-to-point has to be into the same area. Right? So area 0. Now what is area 0? This is known as transit area or backbone area. Transit area or backbone area. These are known as non-backbone areas. The clause was this, that if area 1 has to talk to area 2. See, this might be, let's say, Vizag. This is Delhi. This is Bangalore. And Vizag and Bangalore are connected via Delhi. So Vizag guys cannot talk to Bangalore guys until or unless they have a direct connectivity with Delhi routers or the backbone area. So they have to have a direct connection with area 0 in order to talk or in order to communicate. So the router, which has one interface in one area and another interface in another area, is known as area border router. What it is known as area border router, ABR. And let's say if I want to connect more sites probably somewhere in near to Bangalore, what is there? Kunnur or what? What is there near to Bangalore? Mangalore site is there, or one more name. No, Mysore is there, right? So let's say one more office comes in Mysore. Now, for that, this is R6, right? Now, this router has one interface, let's say in EIGRP. Let's say I want to implement EIGRP.
Madam,
And another interface, OSPF. Yes?
screen is not updating, madam.
Screen is freezed.
Yes, ma'am.
So this R5, who has one interface in OSPF area and another interface in this EIGRP is known as ASBR. What is ASBR? Autonomous System Border Router. Autonomous System Border Router. ASBR. Autonomous System Border Router. right? So any doubts here? Any doubts here? You can take a screenshot of this.
Ma'am, please repeat once, ma'am.
Please repeat once. देखो, there are areas in between 0 till 65,535, right? In this range, area 0 is the backbone area or the transit area. Other areas are the non-backbone areas, but the conditions are that the area non-backbone areas have to have a direct connectivity with the backbone area. Otherwise, they will not exchange the routes. If they will not exchange the routes, they will not be able to talk with each other. Let's say I have Ericsson company who is in Vizag, one office. One office of Ericsson is in Delhi. One office of Ericsson is in Bangalore. Now, Ericsson Vizag guys has to definitely they have to talk to Bangalore because it is Ericsson, and they have to exchange a lot of things because they all belong to Ericsson. So whenever as a network guys we are implementing the network, we have to design the network in such a way that the from Delhi Ericsson there has to be a direct fiber till Vizag or Bangalore. Then only Vizag and Bangalore guys can talk to each other. Got it? So the router which has the different interfaces in different areas is area border router. And the router, let's say Ericsson, one more site is coming in Mysore, but I don't want to implement OSPF there. I want that EIGRP, let's implement EIGRP or let's implement RIP. But this router is again a border router because its one interface is in OSPF, which is configured with area, and another interface you are going to make it is in EIGRP. So this is an autonomous system border router. Got it?
Yes, ma'am.
Any doubts now?
No, ma'am.
No, ma'am.
Very good. But this is really very important protocol because this is something which is used, which is implemented in lot of organizations. Even cloud guys are implementing this protocol in their data center. So this is the same architecture they are following. You will find lot of routers in areas. So wherever you will find the concept of area, it is OSPF, right? So first state is down state. Down state says that both the routers are not saying anything. Second state is init, where one router will start initializing a hello to another and another router starts initializing a hello to another router. Hello, hello. But who is hello? Hello means my router ID. Who am I? My router ID is not my name. My router ID is the highest IP address configured on me. Highest IP address configured on the physical interface of the router. So it has also its RID. Third state is down, init, xstart. Xstart is I will start exchanging the database first. Why? Because I might have a higher router ID than you. Let's say it might have a higher router ID, it has a smaller router ID. So it says I will start exchanging my database first. So here is my database description. What it has? My area, my hello timer, my dead timer, my authentication password, it will also send its DBD. So both the DBD packets, database description in which all the neighboring parameter lies, is there. Then the next one is Xstart. Next state is exchange. Exchange, both the database packets are exchanged. It has its DBD, it has its DBD. So I have the database packet of 2, I have the database packet of 1, I was R1, I am R2. Xstart, exchange, loading. So now they matches the parameters and they say, wow, we both are same. We both have same area. We both have same subnet. We both have same hello timer, same dead timer. So let's become neighbors. So, but before becoming neighbors, they both will start. Probably they might be connected by n number of paths. Now they will think, what is the best path to reach to exchange the routes? So it says, okay, this is 1 gig, this is 10 gig, this is 40 gig. I can see that this is the best path. So can you send whatever you know? It will ask. This packet is known as LSR packet, link state request. So this request is sent by R1 and this is R2. R2 says, yes, here is what I know. Link state update. And once it receives the update, it will send an acknowledgement. Link state acknowledgement. Link state acknowledgement. So it has the database of R2, it has the database of R1, and it has the full database of the routing that, okay, probably R2 is having 2.0, 3.0, 4.0, it comes here. 2.0, 3.0, 4.0. I'm learning via OSP. And probably it might be having 1.0, 2.0. So it goes here 1.0, 2. This I'm learning via OSPF. And on the same time, it calculates to reach you are the best path. So the neighborship becomes full. So this is full neighborship established. Got it?
Yes, ma'am.
So what are the states? Down, init, xstart, exchange, loading, full. Packet types. Hello. Second, database description, which has the neighborship parameters. Third, link state request, where the router was requesting for the routing updates. Then link state update. This is LSR, this is LSU. Then LSA, link state acknowledgement. Link state acknowledgement. Got it? ये पैकेट टाइप समझ में आ रहे हैं ना आपको? हेलो, in which router ID exchanges, then DBD, in which the neighborship parameter exchanges, then the router sends the request to the other router to exchange the routing updates. Once it receives, it sends, and once it receives, it sends an acknowledgement. Okay?
Yes, ma'am.
Yes, ma'am.
Good. Very good. Now there is one more thing which works here. This is a lengthy protocol. So here, let's say I have made Raj Kumar to take care of my Delhi location. And I have made Srikanth sitting here to take care of my Bangalore location. Now, let's say they are connected. The IP which Raj has given is 192.168.1.1. And to the WAN side, he has given 192.168.2.1. To the WAN side, he has given 2.2. To the LAN side, Srikanth has given 3.1/24. What is the router ID of R1? Anyone can tell me. What is the router ID of R1?
Two dot zero, madam.
Yes, 2.1, not 2.0. This is a specific IP. So its router ID is 2.1. And what is the router ID of R2? This is big or this is big? 3.1. 3.1. Fine. 3.1 is big, right? Then 2.2. Highest IP address becomes my router ID. Raj from Delhi location has asked Srikanth to take out the cable of port number 1. But by mistake, Srikanth has plugged out the cable of port number 0. After 1 minute, Srikanth has realized that he has taken out a wrong cable. And by that time, there is an escalation that Ospf neighborship goes down. That means there is an escalation that Delhi to Bangalore link is down. So all the users of Delhi were not able to communicate with Bangalore. What was the problem? The problem was not a fiber cut. It was okay. It was very much okay. Then what was the problem? Because of something which Srikanth has done unintentionally, the link went down. And there was a huge work loss. So Srikanth is going to give the accountancy of this every time. Probably there might be a port flap as well. Might be port, might be flapping, or might be port got corrupt. So I cannot rely on the original identity of the router to original IP address of the interface of the router to become the router ID. नहीं क्यों? So R1 and R2, they become neighbors. But now because of something which is not feasible, it went down. So I don't want that. So what happened that what I did, I said that I will not rely on the router ID of the physical interface. I will not allow physical interface to become the router ID. So what I will do, I will configure a loopback interface. I will configure a loopback interface which will become the So I will configure a loopback interface which will become my router ID. right? So I will never rely on the physical interfaces to act like as my router ID. I will always ask the network guys to configure a logical interface. Since this interface is logical, it will never goes down. So it becomes my most trustable router ID. Now, if Srikanth is going to unplug this cable and after a minute, he is going to plug it back, there will be no downtime. Why? Because the fiber is intact and the router ID is very much dependent on a logical or a virtual interface, which will never go down. You know that, right? The last thing which comes here is um, the multi. I have not written one more feature. Here, the one more feature I have to write is multicasting. So it doesn't broadcast, it does multicast. And there are two IP addresses for multicast. Right? These are two addresses for the multicast. Fine. Now, there is one last thing about it. Unlike your EIGRP or RIP, it uses wildcard masking. Now, what is wildcard masking? It is exactly opposite to subnet mask. Subnet mask. If you are writing 192.168.1.0/24, what is the subnet mask of this? इसका subnet mask क्या होगा? What is the subnet mask of this? Yes, tell me.
255.255.
This one? Fine. यही होगा? Yes.
Yes, ma'am.
So, what is the wildcard mask? Zero dot 255. It is exactly opposite. And if you will map it, it will directly give you the broadcast ID, right? If you will map it, it will give you the broadcast. This is the wildcard mask basically. And there is a formula for calculating it. What do? You subtract the subnet mask from the broadcast ID. Subtract the subnet mask. You will get the wildcard mask. Right? This is the WC. Let's say if I give you 192.168.1.0/26, what is the wildcard mask? What is the subnet mask of this? Tell me the subnet mask.
Two 255.255.192.
Very good. And what is the wildcard mask? You subtract this from this value. What is the wildcard mask?
Zero dot 0.63.
Very good. If you will compare this, see, this is the wildcard mask and I'm good. But if you will compare it, this is actually what? This is fixed, this is fixed, this is fixed. And you don't have to calculate the block size or the subnet, like the next network ID like you were calculating. It will directly tell you that I go from 0 till 63, which your subnet mask will never tell you. So it is much more specific as compared to your subnet mask. Got it? Got it?
Yes, ma'am.
Yes, ma'am.
Fine. So we will get into the configuration of the OSPF. This LAN was 1.0, WAN was 2.0, 3.0. The same network I'm taking, 5.0, R1, R2, R3. This I'm taking as area 0. So mandatorily, if this is 2.1 and 2.2, the interfaces, they should be point to point should be in the same area. This I'm taking in area 1. So mandatorily 4.1, 4.2. These interfaces should be in area 1. R2 is an area border router, right? I will configure the loopback interface on R1. I can give any number to the loopback 0 from 0 till 2 lakh. And this is 1.1.1.1/32. I will create one more loopback here, 11.11.11.11/32. On R2, I will create a loopback 2.2.2.2/32. On R3, I will create two loopback 32 and loopback 1 as 33.33.33/32. Now, this 3.0 can be in area 0 or can be in area 1, your choice. And this additional loopback can be in area 0 or can be in area 1. Fine. This everything which belongs to R1 is in area 0. Everything which belongs to R3 is in area 1. Please take the screenshot of this inter-area lab of OSPF. So let's get into the lab part. It will take now time. We will be creating two loopback interfaces here. Once it's gone. Loopback interfaces acts like as a router ID. The highest loopback interface become the router ID, and they are very much act like as the connected interfaces of the router. So you can use them for the testing purposes as well. Enable Cisco show IP route. Right now I have only two connected networks. I will get into the configuration mode, interface, loopback. You can see this up to 2 lakh loopback interfaces I can create. I will give it a number and you can say I don't have to write no shutdown. It's already up because it is logical. IP address 1.1.1.1.255.255.255. Come out and I'll again show IP route. You can see I have 4 connected network entries. I have 4 connected networks. Earlier I was having 2. Now the loopback acts like as my connected route. Right? Now the second router, enable Cisco. Right now, let me check show IP route. I can see 2.0, 3.0, 4.0. I'll get into the configuration. You can refer to your topology. I am doing the same thing what I have drawn in your topology. So IP route. I'll get into last router. If you will see the topology, asked me to create 2 loopbacks. So I will create 2 loopbacks again. Interface address 3.3.3.3 to 5. So IP. Clear? Any doubts? I have just configured the loopback interfaces. I have not configured Ospf. Clear till here? Any doubts? Into the configuration mode. Router Ospf. This is a process number. Process number is local to the router. It doesn't have to do anything with the neighborship. A router can have multiple Ospf processes running. What is connected to me? Just like IGRP, I used to advertise. This is the wildcard mask and area 0. Network to 168.2.0, 0.0.0.255 area 0. Dot 11.11.11, 0.0.0. Any doubts here? Please come back. Clear till here?
Yes, ma'am.
Getting into the second router, Ospf, any number you can give 1, 2, 3, but I'm taking the same number. The same number is not going to affect anywhere, right? You can have different number and you can check it out. So 2.0 first of all I'm taking. What area number I should give here?
Zero.
Very good. 0. See, the neighborship is up. So what it is saying, I'm neighbor with 11.11, my highest loopback interface. Though I have loopback fine, but this I have among those loopback, I have the highest loopback. And it will show that I have been neighbor with whom 2222 because it has a single loopback, so the router ID becomes 2222. Right? Got it? 192.168.4.0, 0.0.0.255 area 1. And the rest 2 interfaces, since this is an area border router, I have the knowledge of both the worlds, area 0 as well as area 1. So it is on me with where I want to keep. So let's say I am keeping this 3.0 in area 0. I want to keep it in area 0. I'm good. I want to keep these extra interfaces anywhere. I feel like I can put in any area. So I'm good. Clear till here? See, this is important. To put it in area 1 and I have to put 2.0 in area 0, 4.0 in area 1. Rest I have the knowledge of both the worlds, area 0 as well as area 1. So it's on me where I want to put my network IDs. So site 3, configuration, router, OSPF1, network 192.168.4.0, 0.0.0.255. Which area?
1. Area 1.
Very good, very good. That means you're understanding. No neighborship here. The neighborship is formed. See, it has detected that I have been neighbor with 2222. And if you will see site 2, it has detected that I am being neighbor with the highest loopback 3333 instead of 333. Now the rest of the networks will be in area 1 only because they don't have the knowledge of anything. Have the knowledge of only area 1. Got it? So let's check the routing table of site 1. So IP route. You can check connected is connected, fine. But I'm learning this 2222 from inter area. 110 is my AD. I will write down the AD value in the documentation. AD value. AD value is 110. Right? So because I have advertised 2222 in area 1, if you remember. So it is learning inter area route. IA is inter area route. 110 is my AD and 65 is my cost, which it has calculated probably approximately as per the bandwidth. So this is a random value as per the bandwidth via the gateway. I am also learning an inter area route 3333. These are my connected networks. I have been learning with the same area route represented with O 3.0. AD value is 110, cost is 65. I have been learning two inter-area routes as 4.0 and 5.0, where 110 is my AD and these is my cost. Got it? OIA is the inter-area route and simple O isn't within the same area. If you will see site to route, you will see all the routes with O. Because here no inter area will come because it has the knowledge of both the worlds. It knows, so everything is within the area. If it is area 0, it's still low. If it is area 1, it is still low. But inside 3 again you will see inter area because it has the knowledge of only area 1. So it can see everything which is learning from area 0 as OIA. Got it, everyone?
Yes, ma'am.
Very good. So if you will see the Ospf configuration, I have written the same thing. On site 1, I have configured loopback. I have configured one more loopback. I have configured the Ospf. On site 2, I have configured a loopback. I have configured the Ospf. In site 3, I have configured the loopbacks. I have configured the Ospf. This documentation I'm sharing with you, and you can configure it. So I'm attaching and I'm sending. This is not actually assignment, but this is not an assignment actually. This is an announcement to the class. What is this? So go ahead, configure it. Whose screen is this? Oh, great. Very good.
Ma'am, okay, ma'am.
Yeah. Very good. Who's this? Srikanth?
Yes, ma'am.
Very good. 333, 33, 4. Press enter. Press enter. Oh, okay. 500. Fine. Perfect. So Srikanth, go ahead, take over the class and update me who all are done. Fine.
Okay,
Fine.
ma'am.
I'm good with this output.